Hi, in this video we're looking at recapping the work that you did last year on integration in the AS course. Now there are two basic things that you did last year with integration. One was to find the indefinite integral, examples that I've got here, and then also to find the definite integral, which is what we've got down the bottom here. I'm going to look at these two separately. So to begin with, to find the indefinite integral, sometimes this is also known as the antiderivative. So in other words, what did I derive to get this function? And we have this formula for the integral of a function, which at this stage we're calling a times x to the power n, the integral of that thing in terms of x, the variable, and that's going to be given by this formula. And we notice the formula works in this way. The power of n is going to increase by 1, and whatever coefficient we had in front of the x, that is going to become a fraction with the new power that we have for x as the denominator. And this particular rule held for all the work that you did last year, provided that n was not equal to 1. And we're going to look at that a little bit later in the course of this particular topic. So if we take this example, the integral of 3x to the power 5 dx, well, I'm going to start off with 3x. I know my power was 5, that was n. It's now going to increase by 1, so it's going to become n plus 1, which is 6. And then I'm going to put the 3 over that power 6. And then to that I must add a constant c, and that obviously will tidy itself up to being a half x to the power 6 plus c. And it's really important that you include that constant at the end. If I have to integrate two terms like this, I'm going to integrate each one separately. So here we go. If we start off with the first term, 3x to the power 3, well, I'm going to start off with 3x. My power is going to increase to 4, and so that's going to be the denominator of the fraction. And, oopsie, and then I'm going to take away the second one. Okay, that was at 4x. The power of x was 2. It's going to increase to 3, and that 3 is going to become the denominator of my fraction for that particular term, and then I'm going to add c. I only have to add one c despite the fact that I had two terms there. Now you can leave it like that, or you can go and put it over a common denominator. I'm not going to bother about that at this stage. That is called the indefinite integral, and this is basically reversing the process of deriving, finding out the function that we started out with, the function that we derived to get to a particular state. The second part of integration that you did last year was to define or find the definite integral. Now the definite integral is slightly different because the definite integral is used to determine the area underneath a curve. The curve is given by the particular function. So we can recognize this particular function as being a parabola, 2x squared. So the parabola is going to look something like that. It's going to be a curve that goes on both sides. And we're interested in finding the area underneath the curve between when x is 1. So this is where x is equal to 1 and where x is equal to 4. So those extremes that I've got in the top and bottom of the integral sign tell me the limits that I'm going to be working with. I want to work out this area here, the area underneath the curve. To do that, I'm going to integrate the function. So I've got my 2x. The power of the x is squared, so it's going to increase to cubed, and I'm going to put that 3 over in front as the denominator of the fraction of 2. And now this case, because I'm dealing with a definite integral, I don't add on c, but I do put some brackets around these and indicate that I'm going to be working between 1 and 4. Having got to that stage, what I'm going to do is I'm going to go and substitute in values there. So this is going to be 2/3 of 4 cubed minus 2/3 of 1 cubed. And when we tidy all of that up, 4 cubed is 64. 64 times 2 is 128. So I've got 128 over 3 minus 2/3. And that will end up with 126 over 3. And I'm pretty sure that I can divide that. Let's just do a quick calculation. 126 divided by 3. That gives me 42. And so that is the answer. The area underneath the curve would be 42 units squared. So that, in a nutshell, is the work that we did last year on integration, and we are going to build on from here. So hopefully you've done the pre-test and you can assess where your areas of weaknesses are and work on those. And now we're going to tackle the main body of the work. I'll see you in the next video. Goodbye.